Unit 11, Day 1. We're going to talk about how to graph quadratic inequalities today. So, there are 5 steps to graphing quadratic inequalities. You should be following along on page 3 in your note packet. Step 1 is you need to determine whether your graph is going to be a solid parabola or a dotted or dashed parabola. Solid or dashed parabola. That's the first thing you need to check, and I'll tell you how to check that on the next page. The second step you have to do is to write your parabola, that's an inequality, as an equation. What I mean by that is you're going to see something that looks like this. Y is greater than x squared plus 3x minus, or maybe plus 2, we'll say. You're going to change that and write that as an equation instead of an inequality. It's an inequality because of this sign right here. We're just going to copy down the exact same terms, y, x squared, positive 3x, and positive 2, but instead I've changed the sign from being an inequality sign to being an equal sign. All right? Then the third step is to graph that equation. Because the inequality is changed to an equation, and there's a couple of ways you can do that. You could factor it and use factored form. You could use standard form with a, b, and c. Or you could use vertex form. And all of those methods of graphing are just fine. We don't really use the direct substitution a whole lot, but you can use that as well. Finally, step 4 is to test a point to see where to shade. And then finally, you will shade based on the test point. And those are the 5 steps. They're going to make a lot more sense once I go through them in order on the next slide. So make sure you have all 5 of those steps written down, and we're going to begin on the next page here, the next slide. So let's go through our steps. Step 1. First thing you need to decide is whether this is going to be solid or whether it's going to be dashed. And the way that you can tell is just like with the way that you can tell whether a line is solid or dashed on the inequalities with lines. You look and see if there's any line underneath the inequality sign. And in this inequality sign, there is no line underneath that would go right there. And because of that, this is going to be a dashed parabola. So when I graph it, it's not going to be a solid line. It's going to be a dashed parabola. And I don't know which way it's going to open. Well, actually, I can tell which way it's going to open. It's going to open upward because A is positive, and it's going to look like that. Okay, good. Step 2. We're going to write that inequality as an equation. Y equals x squared plus 4x plus 4. And so I just changed the inequality sign to an equal sign. That's all I did. Step 3 now is to graph. Okay, so I'm going to graph the parabola, and I can either choose to graph it in standard form like this, or make it factored form, or use vertex form. I can see easily that this is going to factor nicely for me. I know that this is going to be x plus 2 times x plus 2. That will get me my x squared plus 4x plus 4. So that means my x-intercepts are going to be at 2, 0, and 2, 0 again. So 2, 0, that's where my x-intercepts are going to be. I'm going to go ahead and make my graph here on the page. So I'm going to make my x-axis first. I'm going to label it as such. It's my x-axis. I'm going to make my y-axis up here maybe. I can tell I've already made a small mistake though. Some of you probably noticed right away. This should actually be negative 2, 0. Because this, if I set these factors equal to 0, I have to subtract 2 from both sides. X is negative 2. So my x-intercept, if I go just by ones, let's say 1, 2, 3, 4, negative 5. I'm going to go ahead and graph that x-intercept at negative 2, 0. To find the axis of symmetry, I'm going to call AOS, axis of symmetry. It's basically the middle between the two x-intercepts. But again, we're using the same x-intercept twice. So the axis of symmetry will actually go right through that x-intercept right there. And so my axis of symmetry is going to be x equals negative 2. Where's my vertex? should all be pretty simple for you. You've done this for about 3 chapters now. Negative 2, 0. If that's the only x-intercept, it has to touch right there. And now I make my small table. So it's going to be x, negative 2, negative 1, 0, 1, and 2. I'm going to square those values because my parent function is the parabola y equals x squared. I'll just square that. And then I have to multiply by the a value. And the a value in this case is just 1. So 4, 1, 0, 1, 4. All right, I'll graph it, but again, it needs to be dashed. You need to be very careful. It is dashed, okay? So I'm going to graph those. Oops, I'm sorry, made a small mistake there. 2 over 4 up, 1 over 1 up, 0, 0, 2 up. I can go a little bit farther if I want. There we go. And I'm going to make it dashed. I'm not going to color it in all the way. I'm going to make it dashed. Now, if you don't like to make dashed lines like this, you can make it solid and then use your eraser and just erase the little lines like that. Step 4 is I have to choose a test point. So I've determined solid or dashed. I've written it as an equation. I've graphed it. Now I have to use a test point. And basically what that means is just to determine where I'm going to color in my parabola. You should remember this from earlier in the year. And I'm going to choose the test point that seems easiest right here. What are the coordinates of that test point? 0, 0. So I'm going to test with the point 0 for x and 0 for y. You don't have to use 0, 0, and in fact, sometimes it's not the best point to use. But in this case, I'll use 0, 0. I'm going to plug it into my inequality at the very top. 0 is greater than 0 squared plus 4 times 0 plus 4. Now I want to see if that is a true inequality, if whatever I get after I simplify the expression is true. Well, this is going to be 0. 4 times 0 is also 0. And it's easy to tell now that 0 is not greater than 4. So this is not true. Because it's not true, I will not shade where my test point was. I'm not going to shade in there. I'm actually going to shade inside the parabola on the other side. You see there's clearly 2 parts. There's the part inside the parabola and the part outside the parabola. And because this test point didn't work, I'm going to shade inside the parabola here. That's it. I will shade. That's step 5. Step 5 was shading. Oops, don't want to use the highlighter. Step 5 was shading. Okay, so there you have it. 5 steps. Solid dashed. Write his equation. Graph that parabola. Test the point. Shade where it has to go. Now, we don't necessarily have to draw the entire graph to know whether an ordered pair is a solution to an inequality. So, for example, I have the inequality y is greater than or equal to. I'm going to write that down. Y is greater than or equal to 2x squared minus x. That's how I'd read that. Y is greater than or equal to, that's where that little line comes in, 2x squared minus x. And you see I'm given a point, x, y, here to test out. So I'm going to plug those points in for x and y. So I have 6 is greater than or equal to 2 times x squared. What's x? X was 2. That's the test point that was given to me. Minus x, again, and that's the 2. Sorry, my colors didn't switch there. There you go. Let's evaluate the expression and see if it's true. So 2 squared, I have to do that first. I can't multiply 2 by 2 yet. Right here, I can't multiply those two. And I can't subtract 2 minus 2 yet. I have to do the exponents. 2 squared is 4, right? Minus 2, what's 2 times 4? That's 8. All right, so we have 8 minus 2, 6, greater than or equal to 6. Now that is true. And only because I have the line underneath the inequality here. So I would say yes, 2, 6 is a solution. And that's because it's greater than or equal to, and I'm using the equal to part of the inequality right now. All right, let's check number 2. All right, in number 2, I want to check to see whether the point negative 3, 10, negative 3 for x, 10 for y, and I'm going to plug those into the equation, or I'm sorry, I'm going to plug those into the inequality right here. Now, the way I would read this one would say y is less than x squared plus 9x. That's how I'd read that one. So I'm going to plug the numbers in for x and for y and see if this is a solution. 10 is less than x squared plus 9 times x. Let's plug in the x value, which was negative 3. All right, I can kind of already tell what's going to happen here. Negative 3 squared is 9. I have to do that first. 9 times negative 3 is negative 27. 10 is less than 9 minus 27. 9 minus 27 is negative 18. Is 10 smaller than negative 18? Here's how you check. Well, here's 0, here's 10, and negative 18 to be over here. In order for a number to be smaller than a number, or less than, it has to be on the left side of it. But 10 is on the right side. So 10 is actually greater than negative 18, and this is false. So negative 3, 10, not a solution to the inequality. Again, this should hopefully not be completely new to you. This is something that we studied a long time ago with lines. Let's go through our steps again on how to graph, okay? So we have another one here to graph, and we'll go through the 5 steps one more time. First step, should be in orange, sorry. First step, solid or dashed. I looked at the inequality sign, this one's solid or dashed. It should be saying dashed. And I know because there's no line underneath. So it's opening up, so my parabola is going to look like this when I'm done. Step 2, I forgot what color, I think it was blue. Write it as an equation. Y equals x squared plus 4x plus 8. Step 3 is to graph the parabola. Now in this case, it's not factorable. I can't factor very easily, so I'm going to use standard form. So first I'm going to find the axis of symmetry and use x equals negative b over 2 times a. What's the b value? The b value is 4. Negative 4 over 2 times a, which is 1. So I have negative 4 over 2 is negative 2. The axis of symmetry is x equals negative 2. Find the vertex now. The vertex. That I have to plug in negative 2 into my equation for x and find y. So and I'm actually plugging into the blue equation here. Negative 2 squared plus 4 times negative 2 plus 8. Okay, negative 2 squared is going to be 4. 4 times negative 2 is negative 8, plus a positive 8. Again, I had to do that exponent first. 4 minus 8 plus 8 is just 4. So my vertex then is at the point negative 2, positive 4. Okay, I'm going to go ahead and graph my axis of symmetry, my vertex here. Same idea, I have to put my own x-axis on here, my own y-axis on here. I'm going to make my scale, go by ones again, 1, 2, 3, 4, 5, there's negative 5, 1, 2, 3, 4, 5, there's positive 5, and it's at x equals negative 2 is my axis of symmetry, so I'm going to put that up there. There it is. My vertex is at negative 2, 4, I'm going to put that up there, and then I'm going to use the table, and it looks like my a value is 1, so I don't even have to really write the table down. I think at this point you've seen enough tables to do this. It's a standard with parabola. I'm just going out to 3 points here just so to get the shape nice. And I need to make sure after I'm done graphing this that it is dashed. So I'm going to just show you what I mean by using your eraser. You can just use an eraser and just kind of erase the spots here to make it look like a dashed parabola. That might be easier for some of you than trying to draw the dashed line. All right, step 4, I need to test a point. The easiest test point I know is 0, 0. It's down here. Let's see if it works. Okay, let's plug it into the inequality. 0 is greater than 0 squared plus 4 times 0 plus 8. So 0 is greater than 0 plus 0 plus 8. 0 greater than 8, that's not true, so false. That means I'm not going to shade there. So step 5 then is this last step to shade. Okay, and I'm not going to color where the test point was because it didn't work. The test point was 0, 0. And so I'm going to shade again inside of this parabola. Now I know that this isn't good because both examples were inside the parabola. If that test point had worked, I would have shaded all on the outside here, where all this is. That's where I would have colored if that test point had worked. But it didn't work, so I'm not going to color there. All right, I don't think I have time to do this one. We will do this one in class. Make sure that you fill out your note packet as you're going through this. You can also try to do it on your own. I'm sure that you can figure out how to do this, but we'll definitely go through the rest of the examples in class tomorrow. Have a good night. I'll see you then.